All right, a couple more problems from 13.3. We're looking at percentiles, box plots, quartiles, five-number summary type of things. All right, so let's first look at percentiles. So a percentile, you're probably familiar with percentiles if you've taken those bubble tests in high school. You usually get your response or your score based on the percentile that you finished in, right? If you finished in the 90th percentile, that means that 90% of the people scored lower than you, 10% of the people scored above you, right? So in this case, it says Renee scored at the 84th percentile on a test that was given to 12,600 students. And the question is, how many scored higher than her? So you can look at this from two different directions. You can figure out how many students scored below her, because 84% of that number scored below her. So we can say 0.84 or 84% of those 12,600, which comes out to be, I can find my calculator. If you multiply that, you're going to get 0.84 times 12,600, and that's 10,584. So 10,584 students scored below her, below Renee. Guess that could be a guy too, right? We don't know. But so how many scored above her? Well, there was 12,600. If you take away the 10,584 that scored below her, that's going to give you the number of students that scored above her, or 2,016. Right? Or you can say, well, if she scored at the 84th percentile, then that means 16%, or the rest, right? 16 and 84 is 100 of that 12,600 scored above her. And if you plug that in, you're going to see that that comes out to be, well, we know already, it's going to be the same thing. Right? 2016 students scored higher. 2016, either way we look at it, right? You take 84%, that many scored below, which means this many scored above. Or you can say if she scored in the 84th percentile, then 16% scored higher than her, and you're going to get the same result. Okay? So we also want to know how to find quartiles, and quartiles are actually percentiles. All right? So this is number 17, and in number 17 we are asked, these are surveys given to 18 students. One question asked about the one-way distance the student had to travel to attend college. So these are the miles that the students have to travel to get to the college. And we are asked to find the median, the first quartile, and the third quartile. So realize the median, being the middle value, is the 50th percentile, right? The first quartile is the 25th percentile, and the third quartile is the 75th percentile. Quarters, right? Quarter, 25%, median, right in the middle, 50th percentile, third quartile, 75th percentile, 75%. So we've already discussed how to calculate the median. Remember, we said we take the total number of values, which is 18 in this case, and I've already put them in ascending order. So notice these numbers are in ascending order. These are the same values that you see in number 17, but I've already put them in ascending order. And I'm going to show you on your calculator again how to do that, but it is helpful to know that. So you put it in ascending order. The minimum and maximum we're not really asked for, but that's pretty obvious, right? The minimum is 1, the maximum is 85. The median, remember we said we take the number of values, add 1 to it, and divide by 2, and it's that term in the ascending list. So 18 values in the data set. 18 plus 1 is 19 over 2. 19 over 2 is 9.5. So there's not a single value in the data set that's the middle, because there's 18, right? If the number of values in the data set is odd, then your median will be an actual data value in the set. But in this case, it's the average of the 9th and 10th value in the ascending list. So 1, 2, 3, 4, 5, 6, 7, 8, 9th and 10th. So we take the average of the 9th and 10th value, right? We add up those two, we divide by 2, and it's going to be 10. So this is where the median is, right? That's where the median is. In between those two values, even though 10 and 10 is the median, our median is between those two values. And that becomes important when we look at the quartiles, because the quartiles are going to be the median of all the values below what we just found to be the median, all right? So the median of all values strictly below what we just found to be the 50th percentile. Now, the 50th percentile was between these two values, even though it's the same number. So the values below the median includes this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9 values are below the median. So just like we found the median using this expression, we do the same thing, but now with only the values below what we just found. So there's 9 values below the median. 9 plus 1 over 2 is 10 over 2, or the 5th term in the list. 1, 2, 3, 4, 5. That's our first quartile. And then we do the same idea for the third quartile. The third quartile is the median of all the values strictly above the 50th percentile. So again, here's the median, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values above the median. So again, it's going to be the 5th value above the median this time. 1, 2, 3, 4, 5. So this is going to be our third quartile. All right, so that's how you find the median. This is the 50th percentile. This is the 25th percentile. And this is the 75th percentile. All right, and you can put those into the calculator and find those also. Let's do that. All right, if we go to stat and edit, let's see, I've put these, let's go to list 3 here just to check to put these numbers in. So I put them in ascending order. Let's put them in 1, 3, 4, 5, 4, 5, 2 5s, 7, 8, and 3 10s, 7, 8, and 3 10s, and 12, 15, 18, 12, 15, 18, and 26, 28, 32, 26, 28, 32, and 41 and 85. 41 and 85. And now when we go to our one variable stats and put in list 3, we should get the numbers that we came up with for our quartiles and median, 5, 10, and 26. And that is exactly what we came up with, right? The minimum is 1, the first quartile is 5, the median is 10, third quartile is 26, maximum is 85. All right. So that is how to find quartiles using the median formula and percentiles. All right, one more thing. Let's look at how to draw a box plot. And a box plot is sort of a visual representation of the 5-number summary that we have talked about: minimum, first quartile, median, third quartile, maximum. So in this question, this is number 20. On, let's see, page 780. And we are given 2 sets of data here. This is showing heights in inches of 15 randomly selected National Basketball Association, so NBA versus college basketball players. And these are their heights in inches. And we are asked to draw a box and whisker plot for each of the 2 data sets on the same axes and compare them and kind of give a story about them, right? So I've kind of collected all the data here already. These are the NBA players. These are the NCAA players. So once again, if we go back to our calculator, I've already put this in, so it won't take us too much time. Where are we here? There we go. So go back to stats. I've already put these in lists here. I have list 1 is the NBA players here, and list 2 are the NCAA players. So we don't need to re-input those. We can put them in ascending order if we want. Let's go to stat and sort ascending list 1. I wonder if we could put both in. Let's try list 2. I think we should be able to do that. Yes, we go back to stat, edit, and now these are in ascending order. Both list 1 and list 2 are in ascending order. So if we go to 5-number summary, calculate the 5-number summary, 1 variable stats for L1. We should see the same numbers that I have on the board here for our 5 numbers: 75, 76, 78, 81, and 85. And those are the numbers we have here: 75, 76, 78, 81, and 85 is the 5-number summary for this data set of NBA heights. And if we go back and look, we'll see that the 5-number summary for the NCAA data gives us these 5 numbers: 73, 74, 76, 78, and 81. Let's just be sure of that. Go back to stat, calculate 1 variable, this time list 2, and we should get those numbers for our 5-number summary: 73, 74, 76, 78, and 81. All right, so that's a good way to check our work. But now we have the 5-number summaries. So the box plot, the box and whisker plot, is a visual representation of these numbers. So we can see between both sets, the minimum is 73 and the maximum is 85. So I created an axis here that goes from 70 to 90, just so I can fit in all the values. And let's see, I think it gives us specific, it says placing the second plot below the first. So we're going to put the NBA plot above the NCAA plot. So all you're going to do is draw a line at each one of these points for the NBA. So 75, draw a line. 76, draw a line. 78, draw a line. 81, draw a line. And 85, draw a line. Now the 3 middle lines is what your box is going to be constructed by. And then you draw whiskers out to the minimum and maximum. So this is the minimum, this is the maximum, this is the third quartile, this is the median, and this is the first quartile. All right, and then you do the same for the NCAA: 73, so a little bit less, 74, 76, 78, or 73, 74, 76, then 78, which was the same as the median here, and 81 over here. Again, 3 middle lines give you your box, and then you go out to your whiskers, minimum, maximum, third quartile, first quartile, and minimum. So this is what we call a side-by-side box plot for two sets of data. The NBA heights, the NCAA heights. We can see, if we compare them, we can say the NBA has a taller guy, and maybe they're slightly a little bit taller in the NBA, like the minimum is higher than the minimum here. The median is higher than the median. The first quartile is higher. Everything's a little bit higher. So we can make the conclusion just out of this one sample that from this sample and in the NCAA and NBA, the NBA players are a little bit taller than the NCAA players. And that's how you draw a box plot.